Good afternoon everyone, I'm Princess Alparo and our next topic for today is correlation. Sharina already discussed the definition and types of correlation, so let's just have a quick review. Correlation is a relationship between two variables. The data can be represented by the ordered pairs x and y, where x is the independent variable and y is the dependent variable. We have three types of correlation. The first is positive correlation. It's a type of relationship between two variables in which both variables move in the same direction. Therefore, when one variable increases as the other variable increases, or one variable decreases while the other decreases. Next is negative correlation. It is a relationship between two variables in which an increase in one variable is associated with a decrease in the other. If x increases, y decreases, or vice versa. For the last type of correlation, we have zero correlation, when there is no relationship between two variables. Next, let's proceed to correlation coefficient. Computed from the sample data measures the strength and the direction of a linear relationship between two variables. R is sample correlation coefficient, yung parang P which is raw, population correlation coefficient. There are several types of correlation coefficient, but today, I'm going to discuss person-product moment correlation coefficient or PPMC. The range of correlation coefficient is from positive 1 to negative 1. If there is a strong positive linear relationship between the variables, the value of R will be close to positive 1. If there is a strong negative linear relationship between the variables, the value of R will be close to negative 1. There is no linear relationship between the variables, or only a weak relationship, the value of R will be close to 0. So these are some examples of what a graph may look like with different types of relationship. The first is R is equal to 0.50. There is positive linear relationship but it's not very strong. Next is R is equal to 0.90. As you can see, yung point is mas naging close sila. The positive relationship is more stronger than the first one. Next, we have R is equal to 1.0. This is a perfect positive relationship. Yung nasa ilalim is example of negative relationship. We have R is equal to negative 0.5, R is equal to negative 0.9, and R is equal to negative 1. So this is the formula for calculating the sample correlation coefficient. N is the number of data pairs, and the value of R should be rounded to 3 decimal places. To get R, here are the steps. Step 1, make a table. Step 2, find the values of x times y, x squared, and y squared, and place this value in the corresponding columns of the table. Step 3, substitute in the formula and solve for R. Example 1, compute the correlation coefficient for the data shown for car rental companies in the United States for a recent year. So step 1, make a table. We add 3 columns to the right. Fourth column is x times y, fifth column is x squared, and sixth column is y squared. Step 2, find the values of x times y, x squared, and y squared, and place this value in the corresponding columns of the table. So to find x, multiply lang natin yung second column and the third column. So to find the fifth column, i-square lang natin yung second column. And to find the sixth column is square lang natin yung third column. Is kukunin natin yung sum nila. Summation of x is equal to 153.8. Summation of y is equal to 18.7. Summation of xy is equal to 682.77. Summation of x squared is equal to 5,859.26. Summation of y squared is equal to 80.67. Step 3. Substitute in the formula and solve for R. We're going to substitute this value to the formula. So we have 6 times 682.77 minus 153.8 times 18.7 all over 6 times 5,859.26 minus the square of 153.8 times 6 times 80.67 minus the square of 18.7. So we get 0.982. So, the correlation coefficient suggests a strong relationship between the number of cars a rental agency has and its annual income. Let's move on to our example number 2. Compute the value of the correlation coefficient data obtained in a study on the number of absences and the final grades of 7 randomly selected students from a statistic class. So, step 1, make a table. We're going to add 3 columns to the right. So, yung fourth column natin is x times y, fifth column x squared, and sixth column is y squared. Step 2, find the values of x times y, x squared, and y squared. Place this value in the corresponding columns of the table. So, to find x, multiply lang natin yung second column and the third column. So, to find the fifth column, i-square lang natin yung second column. And to find the sixth column is i-square lang natin yung third column. X is sum those. So, summation of x is equal to 57. Summation of y is equal to 511. Summation of xy is equal to 3,745. Summation of x squared is equal to 579. Summation of y squared is equal to 38,993. Step 3. Substitute in the formula and solve for r. So, we have 7 times 3,745 minus 57 times 511 all over square root of 7 times 579 minus 57 squared times 7 times 38,993 minus 511 squared. So, we get negative 0.944. The value of R suggests a strong negative relationship between a student's final grade and the number of absences a student has. That is, the more absences a student has, the lower his or her grade. Example number 3. Compute the value of the correlation coefficient for the data obtained in a study on the number of hours the 9 people exercise each week and the amount of milk in ounces each person consume per week. For our third example, we're going to use Microsoft Excel. To get the correlation coefficient, i-type lang natin yung equals, then correl, then open parenthesis, then drag the data in X, comma, drag the data in Y, close parenthesis. We get 0.067. Since R is equal to 0.067, the value of R indicates a very weak positive relationship between the variables. Let's proceed to the significance of correlation coefficient. Since the value of R is computed from the data obtained from samples, there are two possibilities when R is not equal to 0. The first possibility is the value of R is high enough to conclude that there is significant linear relationship between the variables. And second is the value of R is due to chance. So, dahil nga ang data is a sample from the population, so maybe the value is due to chance. So, we're going to do hypothesis testing to find out if there is significant relationship. We have 3 methods. The first method is traditional method, second is p-value method, and third is using table I. Before we proceed to hypothesis testing, let's explain this first. The sample correlation coefficient can then be used as an estimator of rho if the following assumptions are valid. The variables x and y are linearly related. If we graph the data, the variables should be approximately linearly related. Second is the variables are random variables. Third is the two variables have bivariate normal distribution. A bivariate normal distribution means that for the first of x and y data values, the corresponding y values have a bell-shaped distribution for any given x values, and the x values for any given y value have a bell-shaped distribution. Population correlation coefficient is the correlation computed by using all possible pairs of data values x and y taken from a population designated by the Greek letter rho. In hypothesis testing, one of these is true. Null hypothesis is rho is equal to 0. This null hypothesis means that there is no correlation between the x and y variables in the population. Alternative hypothesis is rho is not equal to 0. This alternative hypothesis means that there is a significant correlation between the variables in the population. Let's now do the hypothesis testing with our first method, which is traditional method. So this is the formula for the t-test for the correlation coefficient with degrees of freedom equal to n minus 2. We have 5 steps. So the first step is step 1, state the hypothesis. Step 2, find the critical values. Step 3, compute the test value. Step 4, make the decision. And step 5, summarize the results. We're going to use the same example, yung sinolve natin kanina sa correlation coefficient. So example number 1, test the significance of the correlation coefficient using alpha is equal to 0.05 and r is equal to 0.982. Step 1, state the hypothesis. Null hypothesis is rho is equal to 0 and alternative hypothesis is rho is not equal to 0. Step 2, find the critical value. df is equal to n minus 2 is equal to 6 minus 2 is equal to 4. And we have alpha is equal to 0.05. So, hahanapin natin sa t-table yung intersection ng alpha at 0.05 and yung ating degrees of freedom na 4. So, ang intersection nila is 2.776. Since it is two-tailed, our critical value is positive and negative 2.776. Step 3, compute the test values. 0.982 times square root of 6 minus 2 all over 1 minus the square of 0.982. So we get 10.4. Step 4, make the decision. Since yung ating na-compute na t-value ay nag-fall sa ating critical region, then the null hypothesis is rejected. Step 5, summarize the results. There is a significant relationship between the number of cars a rental agency owns and its annual income. Second method is p-value method. So we have 5 steps. Step 1, state the hypothesis. Step 2, find the test value. In this case, use the t-test. Step 3, find the p-value. In this case, use table F. Step 4, make the decision. And step 5, summarize the results. Sample number 2. Test the significance of the correlation coefficient using alpha equal to 0.05 and r equal negative 0.944. So step 1, state the hypothesis. So null hypothesis is rho is equal to 0 and alternative hypothesis is rho is not equal to 0. Step 2, find the test value. Negative 0.944 times square root of 7 minus 2 all over 1 minus the square of negative 0.944. So we get negative 6.398. So step 3, find the p-value. df is equal to n minus 2. So 7 minus 2 is equal to 5. Dahil positive lang yung value sa table natin, nahanapin natin yung 6.398 sa row na may degrees of freedom na 5. Nagpo-fall siya between 5.893 and 6.869. Therefore, the p-value is greater than 0.001 but less than 0.002. Step 4, make the decision. The decision rule when using p-value is when p-value is less than the alpha, we reject the null hypothesis. If p-value is greater than the alpha, we do not reject the null hypothesis. Since p-value is less than 0.05, therefore we reject the null hypothesis. Step 5, summarize the result. There is a significant relationship between the number of absences and the final grades of the students. Third method, using PPMC coefficient table of critical value or table I. Test the significance of the correlation coefficient R is equal to 0.067 at alpha is equal to 0.01. Our null hypothesis is rho is equal to 0 and alternative hypothesis is rho is not equal to 0. Next, we're going to find the critical value. df is equal to n minus 2. So 9 minus 2 is equal to 7. Intersection of 7 and at alpha 0.01 is 0.798. So the critical value is positive negative 0.798. Since R is equal to 0.067, then the null hypothesis is not rejected. Therefore, there is not enough evidence to say that there is a significant linear relationship between exercise and milk consumption. Next, let's discuss the possible relationship between the variables. When the null hypothesis has been rejected for a specific alpha value, any of the following 5 possibilities can exist. First, there is a direct cause and effect relationship between the variables, that is, x causes y. There is a reverse cause and effect relationship between the variable, that is, y causes x. The relationship between the variable may be caused by a third variable. There may be a complexity of interrelationship among many variables. The relationship may be coincidental. Discuss natin isa-isa. There is a direct cause and effect relationship between the variables, that is, x causes y. Example, water causes plants to grow. Poison causes death, and heat causes ice to melt. The first thing causes the second thing to happen. There is a reverse cause and effect between the variable, that is, y causes x. Example, suppose a researcher believes excessive coffee consumption causes nervousness, but the researcher failed to consider that the reverse situation may occur. It may be that an extremely nervous person craves coffee to calm his or her nerves. This, y, could cause x. Your nervousness could cause you to drink coffee. The relationship between the variables may be caused by a third variable. Example, if a statistician correlated the number of deaths due to drowning and the number of cans of soft drinks consumed daily during the summer, he or she would probably find a significant relationship. However, the soft drink is not necessarily responsible for the deaths since both variables may be related to heat and humidity. So yung pagtaas ng dami ng mga nalulunod at yung pagtaas ng number ng soft drinks na nako-consume daily is maybe dahil sa summer. There may be a complexity of interrelationship among variables. Example, a researcher may find a significant relationship between student high school grades and college grades, but there probably are many other variables involved such as IQ, hours of study, influence of parents, motivation, age, and instruction. So, kung mataas yung grade natin ng high school, there is no assurance or it doesn't mean na magiging mataas din yung grade natin sa college. Because there is many variables that we also need to consider like IQ, hours of study, and etc. The last one is the relationship may be coincidental. A researcher may be able to find a significant relationship between the increase in the number of people who are exercising and the increase in the number of people who are committing crimes. But common sense dictates that any relationship between these two values must be due to coincidence. So yun lang po yung report ko. Thank you for listening.